So let's just create a scatter plot here quickly in Excel. So for this, we're just going to want to grab the two columns here. We're going to use one as an X and one as a Y. So just highlight these two. Go to Insert, and right here, Scatter Plot. So now, if we look, we have interest rates here, and then the inflation rate here. And you can see that for higher values of inflation, here, 14%, you have a little higher values of interest rate, just about 14 here, 13.9, 13.82. So this kind of shows you the linear trend that we just saw with the correlation values. And if you ever want to know which one is the X and Y, if you look, go to chart design up here, and just go to select data, and you'll figure out the X values right here, the inflation, as we said, and the Y are the interest rates here. You can obviously swap those if you want. You just copy and paste, put these numbers in. So this looks good. We'll click on it. We're up here at chart design also. We want to add a chart element, and we're going to go here for the trend line and a linear trend line. That was just the correlation that we saw, and that's it. Looks good. This would be essentially our linear regression line. So if we had predicted values for, let's say here, inflation rate of about 11% year-over-year change, the predicted interest rate would live on this line right about here. So that's what linear regression is doing. You have all these text options here, chart options for fill and borders if you want to get fancy. So here we are. That's what I was looking for. In the trend line options all the way to the right. Now we can display the R-squared value on the chart right here, or we can display the linear regression equation, and or both. Take this value, make it a little bigger, maybe bold it, and this would be your prediction that I was talking about here. So R-squared value is your percent variation in interest rate that is accounted for inflation. So it's about 50% of the variation just with inflation alone. That's decently high just for a single independent variable. And then this right here would be your y hat, your predicted value. And what you do is just get the intercept, and then you would add whatever value you're trying to predict here with inflation, right? You get this x, so let's say we're interested in 9 or 10. So this 9 value right here, we would just substitute x in for 9, so 9 times 0.908 plus 1.38, and that would be right here. It would live on this linear regression line, and that would be your predicted value right underneath 10. So you can calculate essentially any prediction, average prediction that you wanted for any of the x values here. Then just be aware of extrapolation. So if you wanted to predict an inflation value of 19, we don't have any data for that. It's beyond the range. So we'd have to be very careful in what we predict because we don't have any trends or previous data to really predict this very well. That's called extrapolation. So just be careful of that, that you should be predicting in this range of data here. So you guys will probably see this later on in your academic career. Linear regression is powerful for policy analysis. It's powerful for economics to understand the interplay of two variables. It's pretty powerful in finance, marketing, anything that you're really doing. It's a baseline prediction model. And it's good not only for prediction, but it's good for causality. It can do both of these things, depending on your data and the assumptions that you give the model.